ओके मैंने म्यूट ऑल कर दिया है, तो अब आप मेरे से जो भी करो, चैट करो और अपने आप को अनम्यूट करके बात नहीं करो, इससे डिस्टरबेंस होता है, मुझे आवाज आती है, नॉइस आता है आपका बैक, तो मैंने आप सभी को म्यूट कर दिया है। इफ यू हैव टू से समथिंग यू कैन जस्ट कम टू द ऑप्शन ऑफ चैट एंड सेंड मी ए मैसेज बाय चैट। इसमें एक चैट का ऑप्शन है, so do not speak, just type something and have a chat with me. So so is it okay? Now let us talk about superconductivity. Okay, if you cannot hear me, just you can raise your hand or something by chat that you cannot hear me. I hope, because no message is coming, I hope you can hear me all. So I will go topic wise. Okay, topic wise, the superconductivity is the topic, and with this topic we will continue this series of lecture till it completes. I mean, it can happen in 3 lectures, 4 lectures, whatever time does it take, it's okay, doesn't matter. Now you are all aware about this phenomena of conductivity. So it's a discovery of the superconductivity. So this was done by Kamerlingh Onnes in 1911. So what is the phenomena? As you can see the picture on your right, that basically they were trying to liquefy the helium, and you can see that helium liquefies at very low temperature, around 4 Kelvin. So that is very close to absolute zero. Now you can see this resistance versus temperature curve on your right. Okay, so while measuring the resistance of a mercury, he noticed suddenly that if he reduce the temperature below 4.2 Kelvin, then this resistivity suddenly drops. So you can see this dotted curve where the resistivity is dropping. Now you can see this red dots here, red dotted line. It was expected from the extrapolation that it will follow this red curve, but actually it went down like this. Now the solid curve, as you can see. So this sudden drop in resistivity surprised Kamerlingh Onnes. So it becomes, the resistance became zero. So as you understand, you are all students of physics, that when you want to measure something, you will also have some connecting wire associated with that. So you see that resistivity of the connecting wire will always exist. So it was the resistivity of the system, which is plotted here. You mean you have to have a system of quite high resistance, and when you reduce the temperature to below 4.2 K, you see the sudden drop. And that one can say that practically almost zero resistivity. Now below, if you see carefully, it is written 10 raised to the power minus 5 ohm. So there is a drop in the resistivity of the order of 5, 10 raised to the power of 5 का जो drop है वो हम इसमें देख सकते हैं. So that's a phenomena of superconductivity. Means superconductivity means now there is no resistance to flow. अभी ये पहले तो कंडक्टर था, अभी सुपर कंडक्टर बन गया क्योंकि कोई रेजिस्टेंस है ही नहीं सिस्टम में. If you allow the currents to flow, once you set the current in such superconductors, it will keep flowing, maybe for years, maybe for thousands of years, don't know. People have just observed it, और इसको फिर उन्होंने सर्किट ब्रेक किया एक लंबे टाइम तक. इसको हम persistent current कहते हैं, इस persistent current, so that you know, they had to break it at some point of time, because the current was not stopping because there was no resistance. Okay, so this is the phenomena of superconductivity. तो इसमें हम पहले phenomena को समझेंगे. We will try to understand what is the phenomena of superconductivity के बारे में हम बात करेंगे. और उसके बाद जो है उसको theoretical जो explanation है उसकी हम बात करेंगे. Okay, so now that was all about its electrical properties. Now the magnetic properties of these superconductors are also quite dramatic. Dramatic in the sense that Messner observed one effect when he took some superconductors in the magnetic field. Magnetic field was on, and material was a normal material. And when he reduced the temperature, it became superconductor. So when it became superconductor, it threw out the magnetic field lines. As you can see that magnetic field lines below this picture of, you can see this yellow-red color. This is the picture of Messner. And you can see this where my cursor is moving. This is showing the Messner effect. So this is on the extreme right. You have a normal conductor where magnetic field is penetrating through the conductor. But when it becomes superconductor, this magnetic lines are pushed out. You can see that there is no more magnetic induction inside this. So that is what Messner found. And so they say this magnetic field does not penetrate this superconductor, or it's a diamagnetic property. You know that when we talk about magnets, so magnetic properties of material, there are paramagnet, diamagnet, and ferromagnetic substances. So paramagnets are those who align in the direction of magnetic field, but with a low strength. In ferromagnetism, they align very strongly. You have a very strong magnetic field. In diamagnetic, it is opposite. So suppose you apply field in X direction, this diamagnetic substance will align in minus X direction. So superconductors are basically diamagnetic. That is what was observed by Messner. So this was interesting property of the superconductor. So I don't know when this time will complete and it will just switch off, because this will continue for 40 minutes. We will come back again because today a lot of time took us just to join and all these things. Now we understand, and tomorrow it will be quicker. And now you see, this is the picture which you can see on your screen now. This is the real superconductor, which is circular, which you can see that lying below, and there is a piece of magnet hanging above it. So this is a very interesting effect, that when this material is a superconductor in a round shaped ball kind of thing, and you have a small piece of magnetic block which is hanging above this superconductor. So this is what is Messner effect actually. Now you can see that let us say, suppose there is a north pole of this magnet which is hanging above is towards the superconductor. So you have done this in your lab, that if you have two magnets and if you bring their south poles close to each other, they repel. If you bring north and south, they attract. But if you bring two south poles or two north poles, they will repel each other. So it means actually when it is hanging above this superconductor, basically it means that in this superconducting material, there is a north pole which is induced. And if there is a north pole below downward and north pole upward, it will repel. And because of this repulsion, it is bearing the weight of this magnet. I mean, there is a gravitational force on this magnet which is suspended above, and there is a push of the magnetic field from the below. So it is hanging above in a equilibrium distance. So this is what. So if you are, let us say, trying to induce the magnetic material, put the field inside it, it generates some field in the opposite direction. Okay, and in such a way that the field inside cancels, and uh, and the field produced by the superconductor opposes the field coming from above. So this is like Lange law. If you have heard the Lange law, that um, in the Lange law, this EMF opposes the cause of its production. तो जैसे ही हमने ये मैग्नेटिक फील्ड ऊपर अप्लाई किया, इसके मैग्नेटिक लाए, तो इसमें जो सुपरकंडक्टर है, इसमें एक मैग्नेटिक फील्ड प्रोड्यूस हो गया, करंट इंड्यूस हो गई. So when there is a induction of current, and the induction of current is like they will be in circular fashion. As you know that when currents are moving in a circular loop, they will produce a magnetic field, and in opposite direction, so that they balances the magnet on the top. Now you can see that it is the setting up of the current, because now material is a superconductor, there is no resistivity. It is very easy to set up the currents in such a system. And when you bring magnetic field above, the currents are set in this ring fashion inside the semiconductor, so that it creates a magnetic field and oppose this magnetic at the top. So this is what happens basically in the Meissner effect. Now, now you see that here it is seen that in this curve, if you see this clearly, you have a y-axis and x-axis. On the y-axis, we have plotted the magnetic field, and on the x-axis, the temperature. It tells us that when we want to go from normal state to superconducting state, or superconducting state to normal state, actually it can be done both, either by magnetic field or temperature. So you can see that if you just if you are here, where is my cursor? So at this particular temperature, and you have applied this much field. Now you see, if field is zero means you are along x-axis. So hello. Now I think some of you have unmuted yourself. Some of you, I will request that you mute yourself actually for the time being. And today is our first class. There had been some technical glitches, no issue, but it will be okay. I think from tomorrow we will be quicker. So now, Vani, can you hear me? It seems she can't listen to me. There is no voice going to her. Okay. So you see, there is a magnetic field and there is a temperature. So either you can destroy the superconducting state by applying a magnetic field or increasing the temperature. So if the temperature is below Tc, so inside this, where my cursor is moving, this is a superconducting state. Above this, there is a normal state. So you can see that if here is the temperature and I slightly increase the magnetic field, I just go into the normal state. Okay. So it is not only the temperature, but by application of magnetic field also that I can destroy the superconducting state. So this is a phase transition from normal to superconducting and superconducting to normal state. And this is reversible. So if you decrease the temperature, you go into superconducting state. If you increase the temperature, you go to the normal state. In the same way, you increase the magnetic field, there's a critical magnetic field, you go to the normal state. And if you are below the magnetic field, you are still in the superconducting state. So this is basically a phase transition from one state to other. इस तरह से हम इसको देखेंगे. First of all, let me tell you that this is a empirical phenomena, yet we are discussing the experimental discoveries, what has been discovered, what has been observed, that we are talking about. Its theoretical aspect we will discuss later. Just now I want to take your feedback because I think won't be not much time now. Till now, if you have any question, and I don't possibly we won't be progressing much today. For time being now, I just would like to take your comments, and I'm unmuting you all. So I, I have unmuted you all. Now I will ask. Now you now you see I have to mute all in your back. I just muted you all because again there is some sound coming from somewhere from you and which you cannot control. So you just unmute yourself one by one. Let us say Tarun Kumar, can you unmute yourself and tell me?
Yes, sir.
Hello.
Yes, yes, I can hear you.
तुम आवाज आ रही है मेरी?
Yes, sir, आ रही है.
अच्छा, आपके कुछ बैकग्राउंड में शायद कुछ आ रही है साउंड ना कहीं से?
नहीं सर, यहाँ तो कुछ नहीं है.
अच्छा अच्छा, ये इसमें कुछ डोंट नो इको हो रही है कुछ साउंड. तो मेरा जो लेक्चर है वो साफ सुनाई दिया जो मैं बोला?
Yes, sir, सुनाई दिया, सारा सुनाई दिया.
अच्छा ठीक है, मैं थोड़ा सा एक एक लोगों से और कंफर्म करना चाह रहा हूँ.
Yes, I will
अभी
get myself.
हाँ मैं अभी तुम्हें म्यूट कर लिया, ठीक है. नाउ नवीन कुमार.
यस सर.
मेरा जो लेक्चर है वो ठीक सुनाई दिया?
यस सर.
ओके गुड, बस यही मैं अभी पूछ रहा हूँ. अभी तुम अपने आप को म्यूट कर लो.
ओके सर.
अशीमा रावत.
यस सर.
मेरी आवाज तुम्हें ठीक आई?
यस सर.
ओके. सो आई थिंक जो ये बता रहा है कि टाइम इज रनिंग आउट. 40 मिनट की जो लिमिट है इसकी वो ऑलमोस्ट होने वाली है. तो इसका रिकॉर्डिंग भी मैं समझता हूँ हो गया होगा. और अगर हम इसको थोड़ा एक्सटेंड करना चाहते हैं तो फिर थोड़ा सा हमें लगता है कि ब्रेक देके दोबारा से शुरू करनी पड़ेगी. तो कल मैं सेम टाइम ही इसको 11 बजे ही रखूंगा एंड वी विल प्रोसीड. आज थोड़ा सा गड़बड़ रही क्योंकि आप भी अपने आप को देख लीजिए कि आपको क्या चाहिए. आपको ज्यादा डेटा आपका ठीक है, नेट ठीक है, आपका इंस्टॉलेशन ठीक है. एक दूसरे के साथ जूम मीटिंग करके देखिए ताकि आप टेस्ट कर पाए कि आपकी जो जूम मीटिंग है वो ठीक चल रही है. तो कल हम जल्दी कनेक्ट करने में ज्यादा टाइम नहीं लगाएंगे, मे बी 5 मिनट में कनेक्ट कर पाएंगे और फिर लेक्चर हम सुन पाएंगे. ओके तो अभी और नेक्स्ट कौन है? अशीमा रावत. शुभम चौहान.
यस सर.
ओके तो आप एक एक अपने आप को म्यूट करते रहो. शुभम ओके यू कैन लिसन गुड. एंड नाउ मोहित डोगरा.
यस सर.
मुझे आवाज सुन पा रहे हो? लेक्चर ठीक से आवाज आ रही है मेरी?
सर ऑडिबल.
ओके एंड नाउ दीपक. दीपक सेंसेट.
यस सर.
मुझे सुन पा रहे हो?
यस सर. यस सर.
ठीक है, ठीक आवाज आई. गुड. एंड आई डोंट नो ये जिन्होंने लिखा है Realme 3i, पता नहीं ओरिजिनल नाम क्या है. यहाँ जो यूजर नेम दिखा रहा है Realme 3i ऐसे करके. शैलजा चौहान. यस शैलजा.
यस सर. यस सर.
ओके ठीक है, मैं अभी आपको म्यूट कर देता हूँ. कुशल कुमार. कुशल कुमार. ओके. अखिलेश गौतम.
यस सर.
ओके गुड. मनुज कुमार.
Yes, sir.
ओके गुड. यासीन भट्ट.
यस सर.
ओके ठीक है. मुकुल भारद्वाज. मुकुल भारद्वाज. लगता है कुछ ऐसे हैं जिनको हमारी आवाज नहीं गई है. अंकित धीमान. वाणी. दिव्या मनकोटिया.
यस सर.
ओके कौन बोला अभी बताओ?
सर दिव्या.
ओके दिव्या. ओके वाणी. आज आप सभी ना थोड़ा एक दूसरे के साथ इस जूम के साथ कांटेक्ट करके देखो और इसमें जो प्रॉब्लम है अपने सेटअप में वो सॉल्व कर लो. ओके, नाउ अंजलि,
Yes, sir.
अब मेरी आवाज आ रही थी आपको?
Yes, sir.
ओके, ठीक है. आशीष कुमार.
यस सर.
ओके, गुड. चेतन कुमार. ओके, ठीक है. चेतन कुमार एंड उसके बाद नेक्स्ट आप सभी अपना हैंड रेज कर सकते हैं क्योंकि अभी इसका शायद 40 मिनट हो जाएगा तो ये चला जाएगा. गैलेक्सी जे, ये कौन है? J2 Pro गैलेक्सी. अभी इसमें आप अपना नाम से डालेंगे तो ऐसे पता नहीं चल रहा है. गीतिका महाजन. ओके. पूनम शर्मा. रंजीत कुमार. ओके. दिस नाउ काव्या, प्रगति, वैशाली, यहाँ तक इनका ऑडियो नहीं दिख रहा है. बाकी सूरज कुमार, स्पर्श.
यस सर.
ओके, गुड. देन आई अंडरस्टैंड. मोस्ट ऑफ यू कैन नाउ लिसन टू मी. अगर आप में किसी के प्रॉब्लम है तो उधर से ऑडियो में प्रॉब्लम है आपके, उसको आप एक बार सॉर्ट आउट कर लीजिए. और ये एनीवे जो ये रिकॉर्ड हो गया है जो भी है इसको हम लिंक शेयर कर देंगे. और कल यहाँ से जहां हमने छोड़ा है कल हम यहीं से शुरू करेंगे इसको. तो आज आप थोड़ा सा आपस में एक दूसरे के साथ जूम मीटिंग करके थोड़ा सा इसके साथ कॉन्फिडेंट हो जाइए कि ये कैसे हम एक दूसरे के साथ बात कर सकते हैं और फिर हम यहाँ पे इसको सब करेक्ट हो जाएंगे कल के लिए. सो नाउ आई एम स्टॉपिंग द शेयर and now I have started my video. Now you can see my video. You can see me.
यस सर.
Okay.
Yes, sir.
Sir.
Yes, sir.
Okay.
यस सर. यस सर.
Good. तो थैंक यू. देखिए पहला दिन था तो आज थोड़ा सा मैस अप रहा, हम ज्यादा नहीं कर पाए. कल से हमें पता चल जाएगा कि हम कैसे कनेक्ट करें एक दूसरे के साथ और आई थिंक वी कैन कोऑर्डिनेट इट वेल. तो अभी ये मीटिंग क्योंकि 40 मिनट इसके हो गए, सो नाउ लेट अस लीव दिस मीटिंग. आई एम एंडिंग दिस मीटिंग एंड टुमारो वी विल गेट एट द सेम टाइम. आप थोड़ा सा 4-5 मिनट पहले कोशिश करें कनेक्ट करने की. मैं फिर से लिंक भेजूंगा और यूजर आईडी मीटिंग वगैरह आपको भेजूंगा कल के लिए 11 बजे के लिए. ओके.
Yes, sir.
ओके सर.
ओके. ओके.
Okay, thank you, sir.
Thank you.
थैंक यू सर.
Thank you.
Thank you, sir.